In this lesson, you'll learn how to create a small network of virtual machines that will simulate a company network. You'll also learn how to configure SSH key authentication and execute commands on remote systems via SSH. What we're going to do here is actually create 3 virtual machines. We're going to name the first one admin01, the next one server01, and the third one server02. And I may call those server 1 and server 2 to be brief. This type of setup is very common where you'll have one server acting as your main administration server that will act as the base of operations, if you will, and then several other servers on your network that are used to do the work for the business. They could be web servers, database servers, or what have you. So here I'm on my local system with my terminal open. I'm going to go to shell class, and I'm going to create a new directory for this project. I'm going to create a directory called multinet. So we're going to be using multiple machines here on this miniature network. So I'm just going to call this multinet. Change directory in there. And let's go ahead and initialize our Vagrant project. Vagrant init, and then supply a box name. Now I just need to edit the Vagrant file and make some changes. I'm going to add some configuration right here below the config.vm box line. And what I'm going to do is say config.vm.define. And we're going to define our first server of admin01 and put that same name here in pipes. Give this an IP address, and then close our statement for this particular host. So this will create one virtual machine. Now let's go ahead and create a stanza for our next virtual machine. We'll call this one server01. Give it the host name of server01. Then we're going to pretty much duplicate this, but make sure we change the 1s to 2s here. And also make sure we change this IP address here. Okay, so now we have these 3 stanzas for our 3 different servers. We have admin01, server01, and server02. So now what we're going to do is run Vagrant up. Now, when you're working with a Vagrant multi-machine setup like this, when you run a command, it runs that command against all the systems unless you specify which one of the virtual machines that you're working with. So if we run Vagrant up, it's going to bring up all 3 of those systems. If we run Vagrant up admin01, it's only going to bring up that system, for example. So we'll go ahead and run Vagrant up and let Vagrant create all 3 of those systems. By the way, this is going to take an extra few minutes since we're creating 3 servers here at once. Okay, now that the Vagrant up command has been executed, we should have 3 running virtual machines, and we can check that with Vagrant status. If you get an error after you run Vagrant up, or if you run Vagrant status and not all 3 of your virtual machines are running, you need to check the contents of your Vagrant file. And let me just jump in the Vagrant file really quick and talk about a couple of things that I've seen in the past, some little gotchas, if you will, and how to get around those. So let's look at our Vagrant file here. And one thing I've seen happen is, for example, on the IP address line, I've seen people accidentally forget the closing double quote. So that is a common mistake. I see people miss a comma here. That is a mistake I've seen before. I've also seen some students do this. They'll use capital IP instead of lowercase IP. So every little thing you see here, every little bit of syntax, it's not like salt and pepper or some seasoning. It is exact and specific. It has to be exactly this way. It's not there for a random purpose. Also, another thing I've seen here, when someone gets to this third stanza, maybe they did like I did and they copied the first one, but they forget to change this. So they have this situation where they're really trying to define server 2, but in the code block here, they're referencing something that does not correspond to that. So it needs to be the same here as well. And I've also seen this happen, which is people leave off this first bit of information here, just use vm.hostname and so on like that. And so that is also not going to work. So again, if you run Vagrant status and not all three of your machines are up, or the Vagrant up command didn't complete successfully, these are some things that you can check. So I'm going to jump out of here right now. And now what I'm going to do is run Vagrant SSH. Now in the past, we've just been working with one system. And when we run Vagrant SSH, we get connected to that one virtual machine. Well, since we have 3 virtual machines, if we run Vagrant SSH, Vagrant doesn't know which one we're trying to connect to. So we have to be very specific and tell it which machine we're going to connect to. And so what we're going to do is connect here to admin 1, our administration server, and start working there. So I'm just going to type in Vagrant SSH admin 01. Now that we're in this virtual machine, I'm going to see if I can ping those other virtual machines on the network here just to see if they're responding on our network. So I'm going to do ping-c3. That means send a count of 3 packets to 10.9.8.11. Sure enough, we're getting responses and that worked. I'm going to do it to .12. Okay, 3 packets transmitted, no packet loss. That looks good. So this particular admin virtual machine can communicate over the network to server 1 and server 2. Now, when attempting to resolve a name to an IP address, for example, if we want to ping server 01, what happens is that the etc host file is checked first by default. And if no entry is found there, then DNS is queried. Since the main point of this class is shell scripting, we're not going to spend the time to set up a DNS server for our 3 little virtual machines here. We're just going to add our 2 servers to the etc host file so we can talk to them by name. Now, if we look at the etc host file, you can see that the format of the file is an IP address followed by a name and then any other additional names that you want to access those systems by. Since I'm a normal user, I'm going to actually use a command called T in conjunction with sudo to append some lines to etc host. So let's look at the T command really quick. The T command reads from standard input and writes to standard output in files. It pretty much passes anything that it receives out the other direction. And so what's useful about this is the -A option, which allows you to append to existing files instead of overwriting. So how this comes in useful in our situation is that we're going to append to an existing file of etc hosts, and so we're going to use the -A option. Now, if you don't append to a file, it just overwrites the file. It clobbers it, if you will. So the reason why this is important is, again, we're a normal user, and what we want to do is do something like this. We're going to echo this 10.9.8.11 server 01, because that's the IP address of server 1. And we want to send that to the bottom of the etc host file. So what happens here is when we execute the command, T sends that to standard output, and it also appends it to the etc host file. So let's do the same thing again here with our server 2. Now, if we cat etc host, we can see those 2 entries are at the bottom of the etc host file. If you're trying to append some data to a file, you may think, oh, I can just run sudo echo, but it may not do what you expect it to do. So let's just try it out really quick. I'll do sudo echo test, and then try to append that to etc host. And it says etc host permission denied. And I get people saying, hey, I ran that with root permissions. Why can't I update etc host? Well, what happens is you're actually executing the echo command as root with sudo there, but the redirection takes place as your normal user, and that is why you cannot append to a file. So sure, you're running the echo command as root, but you're not doing the redirection as root. So that's why you can use sudo in the way we did there. Pipe that output to sudo t-a, and then that way you can do things like append data to files on the command line without an editor and also without switching to the root user. Okay, so that's maybe an interesting aside. Maybe it was totally boring to you, but hopefully you got a little something out of that. Okay, so let's move on. So now we have entries in an Etsy host file. So in theory, that means we can communicate to those systems by name. So we can do this ping-c3 server 01, and you can see 10.9.8.11 is the IP address that it's communicating with. And of course, that is what is in the Etsy host file, and that does correspond to server 1. And we can do the same thing here. Let's just send one packet to server 2, and sure enough, it sends it to 10.9.8.12. As I said earlier, we're going to be using this virtual machine as our main administration server. We'll be running commands from here that will execute on the other virtual machines on the network. So I want to SSH into those other two systems without a password. And the first thing we need to do is create an SSH key pair if we would like to do that. So we'll just run ssh-keygen to generate a key. And we're just going to accept the defaults here. Sure, that's a fine place for the key. We're not going to use a passphrase. And what this will allow us to do is SSH without being prompted for a password every time we want to connect to a server. So we'll just hit enter a couple of times, and now our key is created. So the next step is to put the public key on the remote system, and there's a handy command that will help you do that, and it's called ssh-copy-id. So we're going to SSH copy ID to server 01. Here we're connecting as the Vagrant user over SSH to server 01, and it's saying, hey, here's the fingerprint of that host. Do you accept it? And do you think it's where you're trying to go? In theory, we could check this key on the other side and confirm, but we're on a test system. I'm sure this is going to be safe. So we'll just hit yes here. So here it's prompting us for Vagrant's password, and the password for Vagrant is Vagrant. Okay, it says it added a key over there, so let's check it out. SSH server 01, and you can see that our prompt changed to server 01. So we're on the other VM over SSH. So now I'm just going to exit out with exit. And if I wanted to, for example, run a command over there on server 01, I could do this, SSH server 01, and then specify the command. So let's run the hostname command over on server 01. So what happens is we connect to server 01, then execute the command, and then we're disconnected and we're back to our initial system. So it's like we never connected over there, but we really did. It just wasn't an interactive login. So we need to do the same thing with server 2. So SSH copy ID server 02, accept the key, enter our password, and we should be good to go. Let's just test it really quick. SSH server 02. All right, we get the server 02 prompt. We're over on that virtual machine, and I'll just type exit here. So now this allows us to do things like this. Let's create a little for loop right here on the command line. So I'm going to do for in 1 and 2, do SSH to server 0 in, and then run a command over there, host name, and done. So sure enough, what happens in this little simple for loop is the first time around n is assigned the value of 1. And of course, server 0 $n evaluates to server 01. And then, so that's when we SSH to server 01, run the hostname command. Then the next time around the loop, n is set to 2. And we SSH to server 0n, which is actually server 02, execute the hostname, and then our loop is complete. Again, like I demonstrated above, you can just SSH into any server and run a command without having to start an interactive shell if you supply the command on the SSH command line there. That command you supply gets executed on the remote system, and then you disconnect from the remote system and the output is displayed. Okay, so this allows us to do some things like this. Let's change into our shared folder of Vagrant and create a file here called servers. Notice I used a single redirect operator that created a new file for the first line there. If there was a servers file that existed, it would have been overwritten. And the second time I used double greater than signs, which appends. So I added server02 to the servers file. So let's check the contents of that really quickly. Sure enough, that file only contains two lines, server01 and server02. So then we can do some things like this for server in cat servers. And so remember back that the $ parenthesis command closing parenthesis syntax means take the output of that command in those parentheses and return it, or substitute the output of that command for the command itself here. So what's going to happen is this statement is really going to read for server in server01, server02. So then we'll do this. We'll do SSH server, run the hostname command again. We'll run a second command on that server, and we'll just do an uptime. So first we see the hostname output for server 1, then we see the uptime output for server 1. The loop repeats and we get the same output for server 2. By the way, if you want to make sure that everything you specify after the host in an SSH command gets executed on the remote host, put it in quotation marks. So if we were to do this, SSH server 01 hostname, semicolon hostname, what's going to happen is the semicolon is going to be interpreted as the command separator, which it is, and the first hostname is going to get executed on server 01 via SSH, and then it's going to terminate that command because the colon is a command separator. Then the second hostname on this command line will actually execute on the local host. So let's hit enter to prove that here. So sure enough, SSH server 01 hostname evaluates to server 01, and then hostname command itself returns admin 01 because it gets executed on the local host. So if you want to make sure that everything that occurs on that command line happens on the remote system, you need to put it in quotes. So let's do this. Here what happens is the hostname semicolon hostname command or command group, everything in quotes there, gets executed on the remote system on server 01 in this particular example. So whether you're doing semicolons or pipes or whatever, if you want to make that happen on the remote system, just enclose it in quotes. Of course, normal expansion rules apply. So if you want variables to be expanded, you need to use double quotes like this. So let's say we're going to use variables for commands. So we'll have command 1 variable be hostname and the command 2 variable be uptime. Now what we can do is this, SSH server 01, and then use double quotes because we want CMD1 to be expanded to hostname and CMD2 to be expanded to uptime. The command to view the running processes or the process table is PS. And a couple of options that I end up using often are PS space -EF, which shows every process. The -E and the -F represents the full listing. So it shows a full listing of every process. So let's take the output of the PS command and pipe it to head. So let's do this. SSH server 01, run PS-EF, pipe that to head -3. Only look at the first couple of processes here and hit enter. So what happened with that command is PS-EF pipe head -3 all was executed on server 1. Now we'll get the same output if we do this. PS-EF head -3. But the difference is this time is that the head command is actually executed on this server and not the remote server. In this instance, there isn't a difference, but again, it's something to be aware of. Another thing to keep in mind is that SSH will exit with the exit status of the remote command that was executed, or with 255 if an error occurred with SSH itself. And of course, how do I know this? Well, I read the man page. So let me pull it up for you really quick. We'll do man SSH, and I'm looking for exit status here. So here it is. SSH exits with the exit status of the remote command or 255 if an error occurred. So let me get out of here with Q. So let's do something like this. Let's make SSH error out by giving it a server that doesn't exist. Here it says it could not resolve hostname server 03, and if we check the exit status of the SSH command, we get 255. So if you're writing a script, you can check for exit status 255 to distinguish an SSH error from an error that's coming from a remote command that was just passed on by SSH. So if we do this SSH server 02 that exists, run uptime, and then check the exit status, we get a 0, which was actually the exit status returned by the uptime command. Okay, here's yet another important little thing to know when you're executing these remote commands with SSH. It's actually more accurate to say that SSH exits with the exit status of the last command executed remotely, or 255 if an error occurred with SSH. So let me give you a couple of examples. So there's a command called true that always returns true, or an exit status of 0. And there is also a counterpart to that, which is called false, which always returns 1, which is a non-success or a false here on the command line. So if we do this, SSH server 01 will execute false, and we'll pipe that to true, which doesn't do anything practically, but it's just to show us about these exit statuses. So if we do that, and then we do this, echo $? We get a return value of 0, and that's because the last command that was executed true returned a 0 exit status. So let's do this, SSH server 01 true false, and then when we look at that exit status, we get an exit status of 1 because the false command returned that exit status of 1. Let's say you want any non-zero exit statuses to be returned if you're using a pipe on the remote system. So the way to accomplish that is to use this. So when we check the exit status here, we get an exit status of 1 because that occurred during the pipeline. Now let's look at this. Let's look at the help for set. Pipe that to less because there's a lot of information here. Just going to go down to pipe here. So if we turn on this pipe fill option, the return value of a pipeline is the exit status of the last command to exit with a non-zero exit status, or 0 if no command exited with a non-zero exit status. So this is something to keep in mind if you want to make sure that every command in a pipeline was successful when using SSH. Okay, enough about executing commands on remote systems. Let's write a simple script that checks to see if our servers are reachable via ping or not. So I'm going to name this multinet demo 01. Goes without saying, we start with a shebang, add a little comment to our script here. So we're going to use a file that contains a list of our hosts here, and we just created that at the command line. So we'll just reuse that. And let's put a check in here to make sure that it exists before we try to loop through it. In computer speak, this says if not exists server file, then do something. Another way to say that is if the file doesn't exist, then do something. And the thing we're going to do here is say cannot open server file for whatever reason, and we are going to exit. So I'm going to go back up here and actually put this in quotation marks. So the next step here is just a loop through that file. So we'll do a for loop. This time, let's use a count of 1. I'm kind of impatient. If it can ping in 1, we'll consider it up. And if we don't get a response with 1 packet, we'll be rather impatient and just assume it's down. Ping generates some output, as we know. I'm just going to send all this output to dev null because I really don't care about the output. What I care about is really the return status. I want to know if that command succeeded or failed. And of course, you know how to check that with this. If the status is not 0, then something went wrong. So we're just going to consider the server down. Now, in the real world, if you can't ping a server, that doesn't necessarily mean it's down. It could mean that it's using a firewall that's preventing you from pinging it. It could mean a lot of different things. It doesn't necessarily mean the server's down, but this simplistic example, we're going to assume that it's down, or at least that's what we're going to report anyway. Okay, that will finish up our for loop. By the way, I checked the exit status and said not equal 0, then do down. You could have done the exact opposite. You could have said if the exit status equaled 0, then the server was up, else it was down. So you can do that any way that makes sense in your own mind. That's what I've chosen to do. So I'm going to save my changes, add some execute permissions on this, and then run this script. So it says server 1 is up and server 2 is up. Now let's stop one of the servers, make it go down and not be available over the network, and then try our script again. There's a few different ways to do this, but I'm just going to exit out of admin 01. Now I'm back on my local machine, on my physical computer. I'm not in a virtual machine here. And then what I'm going to do is just halt the server 02 here. And by the way, if you just run vagrant halt, it's going to halt all the systems here that are defined, not just server 02. So I had to specify that. So now I'm going to SSH back into admin 01. Go to the vagrant folder and execute our demo script here. So server 1 came up right away. It's waiting on server 2. And the ping is going to time out and get a non-zero exit status. And our script reports that server 2 is down. I have just a couple of notes here before we wrap things up. First, this relationship that we set up between these systems with the SSH authentication, it's a one-way relationship. We can SSH into server 01 and server 02 from admin 01, but not the other way around. You could set it up that way, but it's just a common practice to have these one-way relationships so that you can designate an administration server to do all your admin work from. Of course, you can set things up to go the other way, but you'll have to do all the steps we did, like add host entries, generate keys, copy the public keys to where you want to log into, and so on. Also, I want to point out a critical distinction when using sudo. Let's look at this command, ssh server 01 sudo id. The SSH command is executed as the current user, and in our case, that current user is Vagrant. We are then connected to server 01 as the Vagrant user. And if we execute the command sudo id, that is being executed as the Vagrant user. In this particular example, the command sudo id is executed as the Vagrant user on the server 01 virtual machine. Of course, using sudo gives us root privileges, and so our ID that we get back is the root ID here. Now, if we do this command, sudo ssh server 01 id, if we were to execute this particular command, it would execute SSH as the root user on our local system. And we are running sudo ssh locally, then we're connecting to server 01 as the root user, and then executing the uptime command on the remote system. So let me hit enter here and see what happens. So here it's asking us about, do you trust this server's key? And we can say yes. And then you may notice here at the bottom of your screen, we have root at server 01. Again, we're executing sudo ssh on the local system, which makes us root first, then we're connecting to server 01. So it's as if we're running SSH server 01 as the root user. So here, if we want to continue this process, we need to enter the root password for server 01, which happens to be Vagrant. So we get the same output as we did running the command the other way, but I just want to make sure that you get the distinction. Running sudo ssh means we're connecting as root to server 01, and to do that, we have to give root's password for server 01. If you want to do this without a password, then you have to generate SSH keys for the root user and copy the public key to the destination servers like we did before with the Vagrant user. Now, some Linux systems are configured such that root logins aren't allowed, so you have to connect as a normal user and then run sudo inside the virtual machine instead of connecting as root. Anyway, I wanted to point out this very subtle but very important difference. And with that, that brings us to the end of this lesson. And now we have a private network of 3 virtual machines configured and running. If you followed along and built your own private network with me here today, that's great. And if not, well, that's fine too, because you'll get a chance to do that in the exercise that follows.